Good day, guys. Today, I'm going to discuss one of the applications of first order, first degree, ordinary differential equations, orthogonal trajectories. In geometry and physics, one of the applications of first order ordinary differential equations is to find a family of curves that intersects a given family of curves at right angles. To name a few, we have the following pairs of orthogonal trajectories. Curves of equal temperatures, these are called isotherms. And curves of heat flow. Another pair of orthogonal trajectories are curves of equal altitudes these are called contour lines. And curves of steepest descent. On the map. Another one, we have equipotential curves. And curves of electric force. These are just some of those pairs of orthogonal trajectories. The word orthogonal means perpendicular. And the word trajectory means cutting across. Okay, guys? So let us consider one member of family. intersecting a member of another family of curves. At right angles to each other. At the point P. Here's the illustration. So we have a curve y equals f of x and another curve y equals g of x coming from the two families respectively. So at point P, line TF is tangent to the curve y equals f of x, while the line T of G is tangent to the graph of y equals g of x. Okay? Since line TF is perpendicular to line TG, their slopes are negative reciprocals of each other. Is equal to, so slope of TF is equal to negative reciprocal of slope of TG. Okay? Hence, we can say that their derivatives of y equals f of x and y equals g of x respectively are related by the following equation. F prime of x is equal to negative 1 over g prime of x. Also, if all the members of the family of curves denoted by f of xy equals c sub 1 are orthogonal trajectories of all members of another family of curves which we are going to denote capital G of xy equals C sub 2, then their respective differential equations are given by m of xy dx plus n of xy dy equal to 0 and n of xy dx minus m of xy dy equal to 0. Okay? This means that once we know the equation of one family of curves, we can determine the equation of the other family. Of curves. That are orthogonal trajectories to the known family. Of curves. Okay? So this means that if I know f of xy equals c sub 1, the equation representing the known family, I can get from here the differential m of xy dx plus n of xy dy equals 0 by eliminating the arbitrary constant C1. And then after that, from this obtained differential equation, we will able to get the differential equation of the unknown family. So that is n of xy dx minus m of xy dy equal to 0. Notice that in this differential equation obtained from this m dx plus n dy, the coefficients of dx and dy are interchanged, but you have to negate this m, okay? And from here, we will able to get, after solving this differential equation, the equation of the unknown family. That is g of xy equals c sub 2. Okay, guys? Let us have some examples. Find the equation of the orthogonal trajectories of the given family of curves. Okay? So number one, let's say we're given x squared plus y squared is equal to c. So this is the known family. Let's get the differential equation of this. So that is differential equation of family F. So to get the differential equation of family F, all we have to do is to eliminate the arbitrary constancy by what? By getting the corresponding differential equation for this. Okay? So getting the differential of this equation, we have 2x dx plus 2y dy is equal to 0. Okay? So where c is the arbitrary constant of this known family. We can simplify this by dividing by 2 to get x dx plus y dy equal to 0. So again, this is the differential equation of family F. Now for the differential equation of family G, the unknown family of curves, we have to interchange coefficients of dx and dy respectively and then negate the second term. So we have y dx then minus x dy equals 0. Again, interchange the coefficients x, this x and y. So we'll now have y and then here x, but this one is negated. Okay? So we now have the differential equation of family G. So all we have to do is to solve this DE to come up with the equation of family G. So solving this DE, we will obtain equation of what? Equation of family G. Okay? So, to solve this differential equation, this is identified as differential equation with variables that can be separated. Okay? So by separation of variables, we have dx over x minus dy over y. Okay? So what I did, I divide each side of this equation by xy. So we now have dx over x minus dy over y equal to 0. The solution for this is given by integral of dx over x minus integral of dy over y, and that is equal to, let's say, k1. Okay? So this gives us ln of absolute value of x. So this is integral of d over u. So that is ln u. Our u here is x. Same thing for integral of dy over y. So that is ln of absolute value of y. So we take absolute value because there is a possibility for x and y to be what? To be negative numbers. So here equals k1. Then simplifying, we get ln of absolute value of x over y, and that is equal to k1. To simplify further, we're going to make each side exponent of e. So hence we have absolute value of x over y is equal to e to the k1, or this is equivalent to x over y, which is equal to plus or minus e to the k1. Okay? Solving for y, we have y is equal to x over plus or minus e to the k1. For simplicity, since plus or minus e to the k1 is just a constant, we can let it, or we can represent it by k, 1 over, that 1 over 1 plus or minus e to the k1. Okay? So hence we have y is equal to k x. So this is the equation of the family of curves that we are looking for, family G, the unknown family. Okay, so that's it. By the way, this y equals kx is a family of a straight line passing through the origin with the slope k. Okay, let us have number 2. 4x squared plus y squared is equal to c. So again, first, we have to get the differential equation corresponding to this by eliminating the arbitrary constant c. So for dE of family F, we have 8x dx plus 2y dy is equal to 0. Okay? So let's divide by 2, getting 4x dx plus y dy is equal to 0. So from here, we can now get the differential equation of the unknown family. So let's have it as family G. So all we have to do is to interchange coefficients. So we have y dx, but we have to negate this second term, negative 4x dy equal to 0. Now, to get the equation of the unknown family G, so all we have to do is to solve this differential equation, okay? So for family G, we have to solve this, no? So to solve this, all we have to do is to what? Is to identify the type of differential equation involved here. So again, I think this is separable. So by separation of variables, we have dx over x minus 4 dy over y, and that is equal to 0. So by dividing what? By dividing by xy. Okay. So integrating this, we have integral of dx over x minus 4 integral of dy over y. And let's say this is equal to k sub 1. So taking the integral, we have ln of absolute value of x. So minus 4 integral of dy over y, that is 4 ln of absolute value of y, and that is equal to k1. So simplifying, we have ln of absolute value of x over y to the 4th, and that is equal to k1. Equivalently, this is equal to x over y to the 4th, and that is equal to plus or minus e to the k1. Okay? So this is absolute value of x over y to the 4th, and that is equal to e to the k1, removal of absolute value on the left side. We have plus or minus on the right side. Okay? So let's solve y to the 4th. Y to the 4th is equal to 1 over plus or minus e to the k1 and then times x. Okay? So for simplicity, because this coefficient is simply a constant, so let it be k. So we have k equals 1 over plus or minus e to the k1. Okay? So hence we have y to the 4th is equal to kx. So this is the equation of the unknown family, every member of which is orthogonal trajectory of what? Of every member of this given family. Okay? So again, this is equation of the unknown family G. So let us have the third one. So let's say we're given x squared plus y minus k quantity squared equals k squared. Okay? This is a family having arbitrary constant k. So there is one arbitrary constant here. So it means once it is eliminated, we will come up with a first order differential equation. So first, let us expand this y minus k quantity squared. So we get x squared plus y squared minus 2ky plus k squared. And that is equal to k squared. So here, we can cancel this out. Getting x squared plus y squared minus 2ky. And that is equal to 0. Okay? So from here, we can now obtain the differential equation of the given family. Okay? So for DE of family F, so that is big F. So we have, we can solve for K here so that we can easily solve or eliminate K. Getting x squared plus y squared, and this is equal to 2ky. So, and dividing by y, we get 2k, and on the left side, we have over k. I mean, on the left side, we have over y. Okay? So let's move this so that it is at the middle of the equal sign. So how can we now eliminate 2k? So by differentiating the left and the right, or getting the differential of the left and the right. So we now have the denominator, differential of the numerator. But the numerator, we have 2x dx plus 2y dy minus the numerator, that is x squared plus y squared, then differential of the denominator, so that is dy, all over the square of the denominator. The right side, since k is constant, times 2, so the derivative of this is what? Or the differential of this is 0. Okay? So simplifying this further, we have in the numerator 2xy dx plus 2y squared dy minus x squared plus y squared quantity dy, and that is equal to 0. Okay? Let's combine those having the same differential. So we have 2xy dx. So 2y squared minus y squared. So that is now y squared, okay? So again, 2y squared minus y squared, that is y squared. 2y squared minus y squared is y squared, then minus x squared, then quantity dy, and that is equal to 0. Okay? So this is now the differential equation of this family F. Okay? So for the differential equation of family G, we have, again, interchanging. The technique is to interchange the coefficients of what? Of dx and dy, but to negate the second term. So getting 2x, y, so y squared, y squared minus x squared, quantity dx, and then here, minus 2xy dy is equal to 0. Okay? So this is now the differential equation of the unknown family. So let's now solve this to get the equation of the family G. Now, what type of first order, first degree ordinary differential equation is this? So this is actually a differential equation with homogeneous coefficients. But let's see if there is another, or there's another type of D involved here. Let's check if if I consider this M, and if this one is N. So I will have partial derivative of M with respect to Y is equal to 2Y. Okay? So what about here? Partial derivative with respect to X is what? Is equal to negative 2Y. So it's not exact. Okay? So this is non-exact D. Let's see if there is an integrating factor that is a function of either X alone or Y alone. Okay? So we get the difference between these two partial derivatives. And this is equal to 2y minus negative 2y, and that is equal to 4y. Okay? And then our divisor here is n, and that is negative 2xy. Okay? So dividing by negative 2xy, we get negative 2 over x. Okay? So it means there is an integrating factor that is a function of x alone. So to get the integrating factor, we have e to the integral of negative 2 over x dx, and that is equal to e to the negative 2 ln of absolute value of x, and that is equal to e to the ln of abs of x to the negative 2, but that is even, therefore simply ln of x to the negative 2. So simplifying this further, we get x to the negative 2. So this will serve as our integrating factor. So this is now what? An exact DE once we multiply by this x to the negative 2. So for exact DE, we have multiply x to the negative 2 in this differential equation, x to the negative 2, y squared, then minus 1, quantity dx, minus 2, x to the negative 1, y, dy is equal to 0. So this is now an exact DE. Okay? If you want, you can verify that. So general solution for this, we have integral of what? Integral of this x to the negative 2, y squared, minus 1, quantity dx. So integrate this relative to x, plus term without x But there's no term here without x. So it means simply this, and this is equal to what? Equals, let's say, k1. Okay? So let's solve this. Let me copy this integral because I'm going to move to the next slide. Okay, let's solve this. So we now have relative to x, the integral of this is x to the u to the n plus 1. So this is -1 over -1. U to the n plus 1 all over -1 because this is u to the n du. So times what? Times the constant. Y squared here is considered constant. Minus x, and then that is equal to k1. Okay? So simplifying, we get negative y squared over x, and then minus x, and this is equal to k1. Okay? Let's multiply by negative x each side, getting x, that is canceled now. So leaving y squared only for the first term. Second term, we have now plus x squared, and then on the right side, negative k1x. So for simplicity, let k be equal to negative k sub 1. Hence, we now have y squared plus x squared is equal to what? K x, or x squared plus y squared equals kx. Okay? So this is now the equation of the unknown family that is orthogonal, every member of which orthogonal trajectory of every member of the given family. Okay? The fourth one. Given y is equal to c e to the x. So find the family of curves orthogonal to this family. So to get the differential equation of this given family, first, let us isolate this constant c by multiplying by e to the negative x to get y e to the negative x is equal to c. Okay? So we can now get the differential equation of the given family. So again, we are going to let this family F. So we get the differential of its side, getting y times differential of this is negative e to the negative x dx plus e to the negative x, because that is product, differential of the first dy, and that is equal to 0. Simplifying, we can multiply this by what? E to the x its side. Okay? So getting negative y dx plus dy, and that is equal to 0. Am I correct? So again, this is negative y dx plus dy. Okay? And again, this is a separable dE. To separate variables, we have what? This integral, this. Now for the differential equation of family G. So we interchange coefficients, no? So we have dx, and then here it will become negative, it becomes positive. So this is y dy, and this is equal to 0. Okay? So this is minus plus, so this is now 1, and this is negative y, but we have to negate, so it is now y. So solving for this, to get the equation of family G. So for family G, we have to integrate this, no? Directly. We can now evaluate this. I mean, we can now integrate this directly. Integral of y dy, and that is equal to integral of dx plus integral of y dy, and that is equal to, let's say, constant k sub 1. So this is x plus y squared over 2, and this is equal to k1. Okay, guys? And multiplying by 2, we get 2x plus y squared equals 2k1. Okay? Again, for simplicity, let k be equal to 2k1. Hence, we have 2x plus y squared is equal to k. Okay? So this is the equation of the unknown family we are looking for. Okay, so that's it.